Hello everyone. Class 12th, topic name peroxide effect, khrasch effect you can call it, or anti-Markovnikov rule you can call it. This effect arises when unsymmetrical alkenes like this one are going to react with HX. And HX we know there are of four type of HX we have: HF, HCl, HBr and HI. HX. Now in previous video we have understood Markovnikov rule in which this H positive, we know HX will break in two parts, H positive and X negative. This H positive was attacking, it's a electrophile, need electron, pi electrons are there between two carbons, so it was attacking on this carbon. Because after this attack we are getting 2 degrees stable carbocation. So the Markovnikov rule was electrophile will attack on that doubly bonded carbon which have more hydrogen atoms. But here, in this case, if we are using with these two reagents, a third reagent, peroxide. Now in this condition what will happen? The H positive is not going to join on this carbon, it will join on this carbon. And X will join on this carbon, which was opposite in Markovnikov rule. So the final product here will be this one. This effect is known as peroxide effect, khrasch effect we can call it, or anti-Markovnikov rule we can call it. Let's try to find out the reason behind it. First we will understand without peroxide what happens there. Without peroxide, the reaction will complete through formation of carbocation. In previous video, we have understood that how this reaction is happening. Its mechanism we have understood without peroxide. But with peroxide, the reaction is not going through formation of carbocation, it is happening through free radical mechanism. And we know free radical mechanisms always happen in 3 steps. Step number 1, chain initiation. Step number 2, chain propagation. And the last step, chain termination. So today we are talking about with peroxide. So let's discuss the mechanism behind peroxide effect. Suppose the reaction is CH3CH double bond CH2 with HX in the presence of peroxide. And I told you in the presence of peroxide, anti-Markovnikov rule will be followed, means X will join here and H will join here. Let's understand the mechanism. Let me first introduce to you peroxide. Here we are going to use benzoyl peroxide. Whose formula is this one. This is benzoyl peroxide. This is peroxide OO over there. So that's why it is known as benzene ring is involved. Benzoyl group is there. So benzoyl peroxide is involved there. So the mechanism is first chain initiation step. Means start of the reaction. The benzoyl peroxides are the initiators. In the presence of sunlight or heat, they will start creating free radicals. Now let's understand first what are free radicals. If any atom have one unpaired unused electron, like this is A atom having an unpaired electron which is not used, means it is not making any kind of a bond. So this is a free radical. In a similar fashion, if hydrogen have one unpaired electron without using it, it is like this, so we will call it hydrogen free radical. Chlorine have one unpaired electron which is not used, we will call it chlorine free radical. So in free radical mechanisms, free radicals are generated. One free radical will react and another will generate. On a similar pattern, the whole chain will continue there. So who is starting that? Benzoyl peroxides are going to start the reaction. Between oxygen and oxygen, the electronegativity is same, so the bond will break from here. One electron to this oxygen, one electron to this oxygen. This benzene I am going to write as C6H5 to understand it. In this fashion, two benzoyl free radicals will generate. Now they will stabilize itself. How? One unpaired electron, this is carbon-carbon bond, so it can break from here. So one electron here and one electron of this oxygen. Unpaired electron, we know what can they do. They can create a covalent bond. So the covalent bond will generate between carbon, and C6H5 will be another free radical over here. Similarly, it will happen here. Between benzene ring carbon and this carbon, bond will break. Unpaired electrons will react and will create CO2 gas. And C6H5 free radicals will generate out over here. Here I have not written C6H5, I am using benzene ring, so understand it please. C6H5 it is. So carbon dioxide gas will generate out. Now these C6H5 free radicals, means benzene phenyl free radicals, will react with HX. Now as I already told to you, free radical mechanisms are happening like one free radical will react with a molecule and another free radical will generate. This is a phenyl free radical is going to react with HX. Oh, C6H5 now I am writing as a benzene ring, will join with this hydrogen and another free radical will generate, that is X, halogen free radical. So this is the first step, chain initiation step of free radical mechanism when alkenes are going to react with HX. Now in chain propagation, what will happen? Let's check. Chain propagation. In chain propagation, we will understand those reactions in which final products are generating over there. In chain initiation, one free radical was generated, X, and now that free radical is going to react with unsymmetrical alkene. This one. Now on what carbon it will attack? We know pi bonds are easily breakable bond. So it is unstable because it contains one unpaired electron. It needs one more unpaired electron to make bond and become stability. So out of these two carbon, one carbon it will prefer to attack. It will prefer to attack on this carbon. Reason? Look, when this bond will break and one unpaired electron will shift toward this carbon, so the next condition will be this, CH3, CH. Now this carbon will get one unpaired electron over here and this CH2 will be joined with X. Now X is stable, this carbon is stabilized and unpaired electron is on this carbon. We call it 2-degree carbon free radical. And if this X attacks on this carbon, 1-degree carbon free radical will generate. You can try by yourself. The same pattern, you have to break a bond and unpaired electron you will shift here, X will join, you will join here and this carbon will become free radical. That will be 1 degree free radical. Now 1 degree free radical and 2 degree free radical, which is more stable, which is more better? 2 degree carbon free radicals are more stable as compared to 1 degree carbon free radicals. So that's why X will prefer to attack on this carbon. Now what will happen next with this free radical? It is going to react with another particles of HX. Now same, bond will break, and this hydrogen will join 1 unpaired electron of this hydrogen, 1 unpaired electron this carbon have, bond will generate covalent bond, and CH2X it is CH2X, and what will release out? X free radical, another X free radical. Now what this X free radical will do? The same pattern. It will repeat the cycle. The cycle will be continue, and you can find our main product is generated over here. Halo alkane. Now where X is joined, you can check in final product, X is joined to this carbon, not to this carbon, which was according to Markovnikov rule. So that's why this rule is known as anti-Markovnikov rule. Now question will arise, sir, why carbon is not joining with X? Why with H? Okay, X can also join here, but what will be the problem? If X you will join here, the two X will be very close, and we know X have lone pairs over there. When they are making single bond, lone pair will have a repulsion problem. They will repel each other. That's why such products are highly unstable. So out of 100 particles, a few particles are making that product, but the major one are making these products. And at last, we will have a chain termination step. In chain termination steps, we write those steps which can stop the reaction. How chain reactions are happening, free radical reactions are happening, like A free radical is going to react with this molecule, AB is generated, another free radical will generate. Now this free radical will react with next molecule, and another free radical will generate. This is BD, C is free radical. So this is the process. Free radical react with molecule, another free radical generate, that free radical react with another molecule, another free radical generate, and chain will be continue. In this fashion, products are generated in chain propagation step. But in chain termination steps, we write those steps which can end up the reaction, which can stop the reaction. For example, we know in this whole process, some free radicals are generated over there, like this was generated, this one. Now suppose, and X free radical was there. Now suppose if these two radicals combine with each other, unpair combine with each other, and bond formation is there. So this will be the product. Now this reaction we will write in chain termination, chain stopping reaction. These are chain stopping reaction. Why? Because in this step, no new free radical is generated. Free radicals are finished, and there is no new free radical which is generated. Like suppose H free radical was there, and C6H5 free radical was there. Now suppose they combine and they create C6H6. So this step we will write in chain termination step. Why? Because no new free radical is generated. These reactions are trying to stop the process. That's why we are calling them chain termination reaction. So similarly, many reactions you can find out which we can write in chain termination step. Now the last point. HX is of four types: HF, HCl, HBr, and HI. Can all show anti-Markovnikov rule? No. Can all show peroxide effect? Can all show khrasch effect? No. Out of these four, only HBr will show anti-Markovnikov reactions. Reason? Propagation steps which we have written in chain propagation step, when you will repeat the video and you will find out There are two steps which I have written in chain propagation step. In the case of HBr, both steps are exothermic. Both steps are exothermic. Exothermic means heat releasing steps. And for chain propagation steps and free radical mechanism, we need heat to be released out. So that heat can be used to bring out chain reaction. In which case both steps are exothermic, it is only HBr. And in HF, HCl, HF, one step is exothermic, one is endothermic, and both can be endothermic, that values you can check. But HBr, both steps are exothermic, so this is perfect for anti-Markovnikov or free radical chain reactions. So this is the end of the topic. Thank you very much for watching the video.